Hi there, my name is Craig Stevenson. I'm with the Auros Group. We specialize in the intersection of building science and data science. Today, I'd like to talk to you about how we use technology to drive building performance, specifically energy efficient buildings and buildings with superior indoor air quality. We use simulation, that is our superpower to do that, and we like to merge it back with trended data during the building operation so that we can operate at the intended levels of performance for the 75-year life cycle of the building. So with that, let's jump right into it and show you how we see this and how this is done. First, I'd like to talk to you guys about the smart building infrastructure, how it's defined, what it is, and how to basically set this up to democratize your data in the building. We need to get the data into one location, one usable area, so that we can use it for multiple advanced data analytical layers and not just one or two. To do that, we need to understand what is an operational technology and how do we get that data from that source. Operational technologies can be anything from building automation systems through lighting control systems, through fire alarms, utility meters, and they produce data, time series data, that we literally want to use in an independent data layer so we can access analytics. So what is an operational technology? Well, this is an example of looking at a hierarchy in a time series database that identifies that. In this particular project, you're seeing the building automation system with all of its data points. Utility metering, there are 3 meters in place here, the primary source meters. Generator, fire alarm, indoor air quality sensors. We have 9 sensors set up in here with lighting control and others. So this is an example of how we aggregate all of that data together in one location so that it can be used to drive performance of a building. So from there, we talk about a converged network. A converged network is utilizing a single IP network to merge the enterprise network, the Wi-Fi data, and phones into your operational technology networks. And those are, as we just discussed. If we do that right, we can save money on structured cabling, conduit, and wiring, and bring everything into one central location that we can start to aggregate that data together. When we say aggregate, a lot of these operational technologies use protocols that are not the same. And data aggregation is bringing all that data into one location so that we can organize the point names, the point values, and the timestamps so that we can start to organize and get it back to our data layer. This is what that looks like. I am logged into a computer on premises in a building, and this is our interface connecting utility, which helps us aggregate that data from a building. The Jace in that building looks like this. This is an example of a Jace cabinet. So you have your Jace, your extender here. This is our computer node that I just logged into, and this is our network switch to bring the data in and manage that data through a building. So that component of what we just showed you right here is how we aggregate that data to get it into the independent data layer. The independent data layer is this, and back to here. So let's go and look, for example, at electric. This is an example of a time series stamp. It's collecting data literally every minute or however we set it up in terms of time, and it's aggregating that data together. A flow meter always looks like this. It's always going to accumulate data. But if we look at other meters and sensors, say we look at CO2 from an indoor air quality sensor, that timestamp looks like this because it's collecting data, and that data is not always going to be cumulative. It's going to be an independent data point. And this is how we look at CO2, just to give you an example of how we store all that data. And then we can do all of our analytics in here. This is a great environment for managing time series data, but it's not always a great environment for how we want to visualize the data. That work is being done from the independent data layer as we connect to all of these different resources or advanced data analytical layers like fault detection and digital twinning. So let's take a look at what that looks like. We go back to our simple dashboard. This is looking at all of our 9 points of the indoor air quality sensors. This is now, your trends are set up down here. This is our owner's project requirement or our project goals. Building metrics are 3 streams of data coming from the building, our meters, invoices, and simulation, and we aggregate them together. These are analytics. This is now, and this is automated. This is looking at one of those parameters, a site use intensity, and we can look at it over the past year, and you're able to see meter, invoices, simulation. This is a 12-month metric, so it's going to not have a lot of volatility to it. Utilities tend to have that volatility. So if we go in here and we look at electric, for example, and again, we want to look at this over the past year. This is meter, and SIM. We can also bring invoices to bear as a point. We have them in the database. So this is custom. We can set this up any way we want for the client's preferences. And if you drill down into any of these data points, you can get to the hourly side of it right here. And we can manage this and we can display this as your custom field hourly. We can toggle between costs and unit of measure, and we can export all this data via CSV. If we go to the air quality side, again, same simple way to look at and manage data. If we look at it for the past year, because it's just easier to see it that way sometimes. And we look at operational SIM, and we want to drill down in operational SIM, that's what that looks like. So we're using the simulation against a trend of data to determine context. We could do it statically, like historically we've done, but using it dynamically gives us the ability to set the building back, zone control building setback so that the building turns off. That's where we're saving a lot of the money. So that's air quality. And then the operational technology. So the idea here is we don't want to die by credential death and we don't want to die by dashboard death, and we want access to our operational technology interfaces. So with one click of the button, we're going through Active Directory and we logged in. We're now using Active Directory. I am on premises. There's my VPN, and I'm connecting to literally all of the operational technologies. So if we click into the BAS, we're logging in with single sign-on user. This will take 1 second to pop up. So in the meantime, I'll go back here. We can do that for on-premises operational technologies, and we could do it for cloud-based operational technologies like density analytics. If we click in there, single sign-on enabled, and we're able to log into this platform here, and we're in. And if we go back over to here, this is still coming in. This takes a half a second to come in, but we can do the same thing literally for our security system, access doors, CCTV, our lighting control. There's an interior and an exterior lighting control, the enterprise network, the Cisco devices, and some on-prem specific operational technologies like equipment controls. And this is still coming into our building automation system. So as this finishes its work, here it is now. As this finishes its work, I want to show you, there's the BAS, that we can also make those connections into twins and fault detection. So let's take a look at how that's done. So if we go into SkySpark, and that is launched right here. Sorry about that. There's SkySpark. So if we go into this particular project for SkySpark and we want to look at the builder, which is how the hierarchy and the points are managed, there is a hierarchy for this project. It looks very similar to our time series database, OSI/PI, because it is. This is how we bring it in. And if we go down to the point level, you'll notice that every one of these points are coming directly from our independent data layer. That's the point. If this doesn't exist, that technology is going to want to connect to the JACE. It's going to want to connect to all of the OTs in the building, and it's going to have 500 connections into our buildings, which makes operations and maintenance challenging. It makes security challenging, but done this way, the smart building infrastructure survives. We can swap out SkySpark with the next fault detection diagnostic. As long as the independent data layer is there, then we do not lose any infrastructure, any data, or any security. So this is SkySpark and how this is done. And we could do the same thing for Code Labs, which is launched over here, and we can make the connection right into a digital twin the same exact way. If we want, we can also bring those analytics, because in SkySpark, if you're in SkySpark, all right, go back in. We're in SkySpark right here, and we want to look at what we do in SkySpark. There's the BAS app. These are fault detection diagnostics. If you're familiar with SkySpark, there's a lot of things you can do with it. It's a really cool piece of software for looking at building performance. We've set up roles, probably 75 roles for fault detection, KPIs, BAS points, and sparks for equipment that's working when it shouldn't. And you'll notice all on here, this is how this comes in. It's visualized. It's kind of a challenging visualization. So the point being is, once you have your data in an independent data layer, we can display that any way we want. So now all of a sudden you're seeing that I can come into this DG Lux environment, our super simple dashboard, create a tab, and literally do all the same things with all of the parameters in here and be able to manage all of our sparks. We can also do notifications and emails, but this is just a much cleaner way to look at things. So the point being is that with the right infrastructure in place, we can take advantage of all of the analytics that are exploding in the built environment today to use them to drive building performance. But building data science doesn't necessarily get us to our climate specific goals by itself. Using building science and data science together in an environment like this gives us the ability to drive to higher levels of building performance like passive house and zero energy, and higher levels of indoor air quality like reset air. So with that, I thank you for your attention today and have a great day. Bye-bye.